Hello and welcome to Notebook. We will start with mensuration in this video. We have studied about surface area and volume calculations of solid structures like cubes, cuboids, cylinders, cones and spheres in the earlier classes. In your present syllabus, we will look at an extension of the same concepts. How and what is in offer? Let us try to visualize certain scenarios to understand the type of problems we may be asked. Imagine a sharpened pencil or an ice cream cone. We have all seen them, right? Take a close look at the shapes. The pencil can be separated as a cone on the top of a cylinder. Similarly, the ice cream structure consists of a sphere on top of an inverted cone. In this video, we will look at some numerical which involve cases where two or more solids combine together physically to create a new shape, that is, a combination of the solids. Whenever we are asked to compute the surface area or the volume of any structure that is a combination of solids, we need to break that solid into its corresponding basic shapes and then calculate whatever is asked for in the question. Let us start with a typical problem involving surface area calculations. A paperweight is made up of two solids as shown in the figure. The base of the block is a cube of sides 8 cm and the hemisphere has a diameter of 5.4 cm. Find the total surface area of the block. Take pi to be equal to 3.14. It is given that sides of the cube is equal to 8 cm and that the diameter of the hemisphere is equal to 5.4 cm. It is important to note that these problems are a bit trickier than the ones you have done earlier. Note that if we calculate the total surface area of the cube and the hemisphere and add the two, we will not have the correct figure. This is because of the fact that an area equal to the base of the hemisphere has to be subtracted from the sum of the areas of the hemisphere and the cube, as this circular area is not exposed. Therefore, the surface area of the solid is equal to surface area of the cube plus surface area of the hemisphere without the base minus the area of the base of the hemisphere. The radius of the hemisphere is equal to diameter by 2, which is equal to 5.4 by 2, which is equal to 2.7 cm. Thus, the total surface area of the solid is equal to 6 side square plus 2 pi r square minus pi r square, which is equal to 6 multiplied into 8 square plus 2 multiplied into 3.14 multiplied into 2.7 square minus 3.14 multiplied into 2.7 square, which is equal to 384 plus 45.781 minus 22.890, which is equal to 406.891 centimeters square. This was a bit tricky, right? The key to success here is concentration. You will need to separate out the solid figures and account for repetitions and exclusions. Let us move to the next problem. A medicine capsule has a length of 16 mm and a diameter of 6 mm. Find its surface area. Here we have length of the capsule is equal to 16 mm. Diameter of the capsule is equal to 6 mm. From the figure, we can see that the capsule is a combination of a cylinder and two hemispheres. Hence, only the curved surface area of the shapes will be considered as the bases overlap with each other. Diameter of the capsule is equal to 6 mm. Radius of the capsule is equal to diameter by 2, which is equal to 6 by 2 mm, which is equal to 3 mm. Total length of the capsule is equal to 16 mm. Therefore, length of the cylindrical portion is equal to length of the capsule minus twice the radii of the hemispheres, which is equal to 16 minus 2 multiplied into 3, which is equal to 16 minus 6, which is equal to 10 mm. Curved surface area of one hemispherical portion is equal to 2 pi r square, which is equal to 2 multiplied into 3.14 multiplied into 3 square, which is equal to 56.52 millimeters square. Therefore, curved surface area of two hemispheres is equal to 2 multiplied into 56.52 centimeters square. Curved surface area of the cylinder is equal to 2 pi RH, which is equal to 2 multiplied into 3.14 multiplied into 3 multiplied into 10, which is equal to 94.2 millimeters square. Surface area of the capsule is equal to curved surface area of the cylindrical portion plus 2 multiplied into curved surface area of the hemispherical portion, which is equal to 94.2 plus 113.04 centimeters square, which is equal to 207.24 centimeters square. With this, we come to the end of the video. As always, let me remind you that scoring good marks in maths requires lot of practice.